So Diego's out here talking about these raisins and these walnuts. He's trying to make this trail mix, right? And you found, so far for slide 1 and 2, did he have combinations that worked? No, he's trying to get to a total of $15. And he's trying to get there with $4 per pound of raisins plus $8 per pound of walnuts, correct? So this slide's asking you to find a combination that does work. I think guessing and checking would be a challenge here. Does anybody have a way that we might be able to find a combination that does work? All right. Well, yeah, I could use math, right? So I have an equation right here. So how could I use that equation to help me? Should I be trying to guess pairs? I could. It'd probably be pretty ineffective. Ivy. We could put it in slope-intercept form. I don't think I would have to. Here's what I was thinking. What was if I just said, like, I'm going to get 1 pound of walnuts? All right, so if we have ordered pair RW, and I say 1 pound of walnuts, could I find how many pounds of raisins I would need? Yeah, so I could say $4 per pound of raisins plus $8 in walnuts means that I can get how many dollars worth of raisins? 7, which means I can have 1 3/4 pounds of raisins. So do you see how I could like use my equation to like test out? Now, like, how many different answers are going to satisfy this equation? Theoretically infinite, right? If we could measure out far enough, you know, like into the point, whatever. But one way we could just get an answer is to put in a value and see what the other value would have to be to make my equation true. You could have also done it 1 pound of raisins. It also would have worked. Why couldn't I do 2 pounds of walnuts?
That would be over.
Lily?
8 times 2 is 16.
Yeah.
16 is already over.
I'd be over budget just with that. Did anybody try intercepts to just get a point that would work?
I did.
So you could have done that as well. You could have said, we'll get no walnuts. We're just going to rock raisins. And that would give us 3 3/4 raisins. So we could have said 3 3/4 raisins and no walnuts. That could have been an option too, right? We did that. We've done intercepts before. So looking at number 7, we got Diego buying these walnuts and raisins still. We already did this equation. 4x plus 8y equals $15, right? So check this out. I'm going to submit this because I'm a student. And see this line? This line has all possible answers, right? And everything in between. This is all possible combinations. So after we get this line, what I want you to do is go and fill out this table on slide 8. Fill out those table of possible answers, slide 8. Again, it'd be hard to look, but you can click on the line, and the line will give you your x, y coordinates on the line. So friends, we got some of that table set up, right? Now, we had that constraint of $15. We have a new constraint, a second constraint. Now, Diego is buying 2 pounds total. So how can I model this constraint with an equation? Who's got an equation for 2 pounds total? Benny, help me out. How am I getting to 2 pounds? What am I buying?
X plus Y.
Yeah, let's do it. X plus Y equals 2. If I take my pounds of raisins and my pounds of walnuts, it needs to equal 2. So this line here has all my values of 2 pounds. If I add my X and Y, I get 2. Should this make me have more answers or fewer answers than just getting a total of 15?
Fewer.
Yeah, we have 2 constraints now, right? So what you're going to do first is you're going to fill out the table with the constraint of 2 pounds. And then I want you to use 10 and 8. You're going to go back to 8, and I want you to look for something interesting after you filled out 10. I'm picking out a very specific point. So check out on number 10. See where I have a 1/4 pound of raisins and 1 3/4 pound of walnuts? That's 2 pounds, right? Right? Okay. Check out on 8. To get to $15, I had a 1/4 pound of raisins and 1 3/4 pound of walnuts. So that specific point gave me $15 and it gave me 2 pounds. It's in fact the only point that satisfies both conditions. All right, so next I need to bring your attention to number 11. So check this out. I'm going to graph both of my constraints. I had $4 per raisin plus $8 per walnut for a total of $15. I also had pounds of raisins plus pounds of walnuts for 2 pounds. You guys good with both equations being on there?
Yeah.
Check it out. Enhance. Enhance.
Wow, yeah.
See this spot right here? It's the only spot, so we proved it with the table. It's the only spot that meets both conditions to have 2 pounds total and $15 total. This is the only point that is on both of those lines. So both lines have infinite answers, but there's only one answer that makes both things true. 2 pounds on the blue and $15 on the red. So this is what we call a solution to a system. Big picture, there's 2 situations. Where do they cross? So we're going to check out this problem about tables. And this is like a real problem like a caterer or someone like that probably has to mess with. Here's what we need. This dining hall, we need 25 tables total. These 25 tables are coming from long rectangles and short round ones. I'm a fan of the short round one, okay?
Me too.
Then, they also need us to know that we need 190 seats total, and it tells us what the different tables can seat. So we have, how many constraints here? 1 or 2? 2. So let's work on making an equation for our first constraint. Who'd like to help me make an equation for our first constraint? Brennan?
For the total amount of tables,
Yeah.
x plus y equals 25.
Yeah, short or long plus short needs to total 25 tables. They told us that. We need 25 tables. There it is. All right. What's my other constraint? JP?
X plus y equals 190.
Well, I need to get to 190. How am I getting to 190, though? So X and Y are the size, the different tables. Right now we're talking people. So we can't just do X and Y, because X and Y would be like 1 and 1. 8X?
Oh yeah, 8x plus 6y.
Yeah, so 8 per long plus 6 per short and round. So this would be our system. All right, is everybody good with our 2 constraints here? We need a total of 25 tables, and we need exactly 190 people. So next we're going to graph these. All right, and then we're going to use the graph to answer the next question. How many of each table? So I need total of 25 tables we established. And I need 8 per long plus 6 per short to total 190. So here's my 2 constraints graphed here. And what's the only point that'll satisfy both things? 20 longs and 5 short and rounds. So you can also check that. All you have to do is this. X is 20, Y is 5. 20 plus 5 is it 25? Okay, X is 20, that's 160. Y is 5, that's 30. Is 160 and 30 190? Yeah, that combination of tables gives me 25 tables and it gives me 190 seats. And that's what we were looking for. All right, so checking this one out. We're looking at our constraints again. And it looks like we have 1680 for 2 large posters. So 2 large plus 3 small to get to 1680. And then 1415 for 1 large poster and 4 small posters. So these are my 2 constraints. And what I can do is I can find where these 2 things cross, and where they cross is the solution. All right, so check it out, friends. We've got a place where they cross. They cross right there. And this would give us all the answers we need for this constraint. 1680, so each large would have to equal $4.95, and each small would have to equal $2.30. And what that means in context is that gets us to our 1680 total, and it gets us to our 1415 total. It's the only place that'll get us to both totals.